A student is provided with separate unlabelled samples of 4 different solutions for analysis. The 4 solutions are known to be ammonium nitrate, potassium sulfate, sodium carbonate and magnesium nitrate, but the student does not know which sample is which. Outline a series of test tube tests that the student can use to identify each. Give the expected observations and ionic equations for any reactions. So a thing that we would need to bear in mind here is that we don't know the tests for some of these ions, but we do know the test for an ammonium ion. We know the test for a sulfate ion. We know the test for a carbonate ion, and we know the test for a magnesium ion, but we don't know a test for nitrate, potassium, sodium. So we're looking to do the tests for each of these different things, and then see what we can find out. Okay, so it doesn't really matter what order you do them in, but I'm going to eliminate the 2 that I think are the easiest 2 first. So the first thing I'm going to do is add acidified, so a small amount of acid, and then barium chloride. Okay, so that's going to be my first test. And what will happen here is potassium sulfate will give a white precipitate. And that is because the barium ions will react with the sulfate ions to give the white precipitate of barium sulfate. Now, interestingly, because we're using acidified barium chloride to remove any ions that might interfere and give us a false positive, what will actually happen is that because it's acidified, sodium carbonate will effervesce as the acid reacts with the carbonate. And we could do like e.g. nitric acid here as our acid. Now, you might want to do this as a separate test, so like add nitric acid and see if you get effervescence, but this would effervesce at this point because the carbonate ions are going to react with the acid. Now, because acid is H plus and there's a 2 minus, we're going to need 2 H pluses. It's going to give us H2O and CO2. The other 2 would give no visible change. So ammonium nitrate and and magnesium nitrate would give no visible change. So these 2 would give no visible change. Okay, so what we're going to do now, so we're going to try and identify one of these 2 now. So we're going to add NaOH to both, and what we would see is that magnesium nitrate would give a white precipitate. That's because the magnesium ions, 2 plus, hydroxide ions are only 1 minus, so we need 2 of them, are going to react together to give magnesium hydroxide a white precipitate. If we warm the solution with NaOH and hold red litmus into the neck of the test tube to test the gas, evolved ammonium nitrate would, and in fact it needed to be damp red litmus, I'll squeeze that in, would turn the damp, it needs to be damp so it absorbs the gas, red litmus paper blue. And that is because the ammonium ions react with the water, the damp part. In fact, let's do it with the OH minus ions to give us the ammonia gas, which will then react with the water to give us ammonium ions to test the test to see that it is alkaline.